Hello and good morning, everyone. This is Suraya Mahapatra from Need Udan. I will be giving you classes for physics of the class 12th chapter of physics, that is semiconductors and electronics. So today's topic is semiconductors, electronics, materials, devices and simple circuits. In lower classes, we all studied about those conductors, semiconductors, conductors, and insulators. We knew those were the mediums to conduct or let pass electricity through them. So the substances which allowed total flow of electrons or electricity to conduct through them were called conductors, whereas those materials or medium in which we can control the flow of electrons within themselves are called semiconductors. We could mold these semiconductors into the users or the makers to let them decide how much or how how amount or what amount of electrons should be passing through them, whereas insulators were the substances or the mediums which do not allow any electrons or any electricity to pass through them. In fact, those devices or mediums or substances were used for daily or day-to-day life, so as to prevent us from getting shocks from the electricity and all. For example, we used to wear rubber chappals and then used to iron our clothes or and all these things. Now, as we are getting older and wiser to know in depth in all those things or substances, we will be studying more about the semiconductors. So, I have made the notes beforehand so as to not to waste the time in writing notes in front of you all. So, let's get started. The devices in which control flow of electrons can be obtained are the basic building feature of all the electronic circuits. Before discovery of transistor in 1948, such devices were mostly vacuum tubes and valves. Vacuum tubes had two-ended electrodes or diodes. They were called as diodes. Such devices were mostly vacuum tubes, or these vacuum tubes were called valves. So, vacuum tube had two electrodes, that is we also call them as diode, because di means two and ode means electrodes from we take the word odes from electrodes. So di means two and two electrodes. Those were anode, or these anode were called plate, whereas other one is the cathode. Similarly, triode has three electrode, that is one cathode, one anode or plate, and another one is the grid. Similarly, there are tetrodes and pentode. As the name suggests, they are with the 4 and 5 electrodes respectively. That is tetrode with 4 electrodes and pentode with 5 electrodes. In vacuum tube, electrons are supplied by a heated cathode. It means where an external heating is given to it, and controlling of these electrons is obtained by varying voltage between its different electrodes. So a voltage or a difference in a voltage was created so that the electrons could move freely from one electrode to other electrode, that is from anode to cathode. Usually, a vacuum or an empty space is required between interelectrodes or in between electrode space. Electrons will lose energy in collision with themselves and with the air molecules. As I said earlier, in these tubes, electrons can flow from cathode to anode, and these were known as the unidirectional because only one directional flow from cathode to anode is possible of these electrons. Therefore, such devices are called valves because there are no backflow of electrons. Now let's know some of the features of these valves. These valves are really bulky, consume high power, operates only at high voltages, that is approximately equal to 100 voltage or more than above of these. Then it had limited life, low reliability because of the loss of energy in between the electron collision. But with the growing technological advancement, there has been a replacement or modification of these old model or earlier version of these vacuum tubes. So, while vacuum tubes needed above tiresome process, though those above tiresome processes, but nowadays no external heating or large vacuated spaces are required by the semiconductor devices, and nowadays those bulky and low reliable devices or semiconductor devices are now being modified into a small size, and they consume very less power, operate at high voltages, have long life, and they're highly reliable. In TVs or televisions, there has been a use of cathode ray tubes for the display of the television screens, but now they are being replaced by liquid crystal display or LCD TVs. Earlier, for the detection of radio waves, we were using the crystal of galena or lead sulfide. Its chemical name is PB lead sulfide and its formula is PBS, with a metal point that was contacted or attached to use as the detector for radio waves. The next topics in class 12 NCRT physics book, we have the topics as semiconductor devices like junction diode, two electrode devices, bipolar junction transistor, three electrode devices. Now, let us know about how there has been the classification of conductors or semiconductors, metals, and all these insulators and all. First, on the basis of conductivity. Second, on the basis of energy bands. In this video or in today's class, we will be completing up to this classification of metals, conductors, and semiconductors on the basis of conductivity, and second on the basis of the energy bands, because till understanding the energy bands, it will be really a hectic process, but I will try my best to make this video an easy one. So, on the basis of conductivity, okay, before moving on, the classification of metals and conductors and semiconductors on the basis of conductivity, let's know what's conductivity. Conductivity are the property of conductors to let electrons pass through them so that they can be controlled. Control means those electrons can be controlled to let electricity pass through them. And so this property is really helpful for the makers of the conductor or the electricians to control the flow of electricity or electrons within these conductors. Now, a conductivity is given the symbol as this symbol. This symbol is called sigma, or resistivity, which is the another fundamental property of these materials or the conductors that measures how strongly it opposes the electric current, and this resistivity is given or assigned a symbol, this one, which is also called as rho, and rho is always inversely proportional to conductivity, which means when resistivity increases, conductivity decreases, which as a result we will be knowing how these are classified. Like, for example, when resistivity is increasing and conductivity automatically decreasing, This will let the substance or the conductor to become an insulator, which will not allow any flow of electrons or electricity to pass through them. So, on the basis of conductivity, there has been three substances. First is metals, which have, of course, a low resistivity so that electron can fully pass through them, and high conductivity so that electrons are easily flow through them. Now, low resistivity, which means it has 10 to the power minus 2 to 10 to the power minus 8 ohm meter, while high conductivity, which means it has 10 to the power 2 to 10 to the power 8 s per meter. Whereas these semiconductors have, of course, have conductivity and resistivity intermediate between metals and insulator. If they will have high conductivity, they will become metal, whereas if they have low resistivity or high resistivity, then they will become insulators. So these are intermediate. These come in intermediate or in between metals and insulators. So semiconductors have conductivity and resistivity in between metals and insulator. So it has a resistivity of 10 to the power minus 5 to 10 to the power 6 ohm meter, whereas conductivity of 10 to the power 5 to 10 to the power minus 6 segment per meter. I have done this with similar to metals. For example, resistivity is 10 to the power minus 2. So for here also, resistivity is 10 to the power minus 5 to 10 to the power 6 ohm meter. Whereas for conductivity, we can know them as 10 to the power 2 to 10 to the power 8 segment per meter. For here also, 10 to the power 5 to 10 to the power minus 6 segment per meter, so as to not confuse the students of this. Now let us know about insulators. Insulators have a high resistivity, that is its rho is high, whereas its sigma is lowest. So high resistivity with 10 to the power 11 to 10 to the power 19 ohm meter, whereas low conductivity of 10 to the power minus 11 to 10 to the power minus 19 segment per meter. Interest in this chapter is only based on semiconductors. So, semiconductors are again divided into two types: elemental semiconductors and compound semiconductors. Elemental semiconductors, or the basic ones, are silicon and Ge atoms of the crystal. And second one is compound semiconductors. These are only examples. We will be studying about them in detail further. So, compound semiconductors are again divided into inorganic, organic and organic polymers. Inorganic comes under CDS, like cadmium sulfide and all these things. GAAS, CD, SE, INP, all these things. So your homework is to find chemical names of these compounds. Then comes as the organic semiconductors: anthracene, doped phthalocyanines, and organic polymers are polypyrrole, polyaniline, polythiophene, all these things. Now let us come on the basis of energy bands. This is the a bit of what we say complex process, but we have to understand in order to make our chapter more easy. To understanding this, Bohr's atomic model is the most important basic or prerequisite knowledge to know these things. So if you haven't, then do the revision on by yourself so as to understand this classification of the materials on the basis of energy bands. But still, I will be trying to make more videos on previous models or the Bohr's atomic model. So Bohr's atomic model says that in an isolated atom, the energy of any electron is decided by the orbit or the path around which they revolve. So the path around which they revolve or the electrons revolve decide how much energy they possess within themselves. So inside the crystal, each electron has a unique position, and no true electrons have same pattern of surrounding or neighboring charges. For example, if it is a negative electron, then it will be surrounded by a positive electron only, and vice versa. But so that's why they are called as they won't be having any same pattern of surrounding or neighboring charges. So because of this, each or individual or any single or isolated electron will have different energy levels. I am giving synonyms to these things so as to make the students more comfortable with the words. Now, these electrons with different energy levels are called energy bands because they come together and form a band-like structure. Or we can say, in other words, these different electrons with continuous energy variation, with continuous differentiate of the variation within themselves form energy bands. It means atoms of different energy levels come together to form energy bands. Now, energy band which include energy level similar to valence electrons is called the valence band. And valence band are raw or very original because they have no external energy within themselves, but they're filled band, and also they're stable, so that's why they're filled band. Now, energy band above the valence band is called the conduction band. It is generally always empty, but when it overlaps with the valence band, electrons move freely into it, hence conducting electricity. And so this is the reason or the sole reason behind the conducting of electricity bit of the semiconductors, whereas in conductors they are always overlapping. And this is the advantage due to which we can control the flow of electrons of the semiconductors. Thus, the process creates the possibility of conduction band due to electrons in conduction band as well as due to valencies in the valence band. It means these are called conduction band because it is the place where all the passage of electrons freely inside the medium or substance takes place, whereas in the valence band they are with each other, or the atoms are with each other tightly packed due to certain valencies in between them. That's why they are called the valence band. This is a small effort that I have drawn of this figure to make it more easy to understand. Valence band is always filled with the atoms, whereas it has a gap between them, and this gap is known as the energy gap, attributed by the symbol E with a subscript of small g, whereas the conduction band is always empty. And so this is the reason why the atoms or the electrons from the valence band move to the conduction band with some form of external heating or according to some external factors. They overlap with each other of the outermost electrons so as to conduct electricity in between them. Before moving further, we have to know the very important topic of semiconductors of the class 12 chapter of physics NCERT book, that is the band theory of solids. This is a graphical representation of the conduction and the valence band and the energy gap in between them, how the electrons interact with each other, and how they conduct electricity in a semiconductor. Now let's take the example of Si and Ge crystals. Always the example of Si and Ge crystals are taken because these are the basic or elemental semiconductors. So let's get started. And these Si and Ge crystals are contained or contains n atoms. Of course, electron of each atom will have different orbits as we have no further. So this contributing towards the knowledge of energy as we knew according to the Bohr's atomic model. So electron energy will be same if all the atoms are isolated or separated by a large distance. Of course, each electron will possess its own power, so all will be same if the atoms are separated from each other by a large distance. Because they are not interacting and hence will not react and hence will have equal or uniform energy levels throughout within themselves. But in a crystal, atoms are very close to each other, a little close to each other because it's measured to be as in between 2 to 3 angstrom they are with each other. And so these will interact or talk to each other or socialize with each other and also with the neighboring atomic cores. There we can take the example or comparison between human and the atoms. For example, you are living in an apartment and you have of course many or different neighbors, different types of neighbors. So they come in the evening to have some tea or snacks in your home and have a bit of chit chat with your family members or with you. So you and your family members are within your house and within yourselves. So let your house be a crystal and your neighbor's house is another crystal. So the members of the neighbor come to your house to meet you and your family. Suppose you are inside and an electron from your neighbor or a member from your neighbor's house come to your house to meet one of the family members. So you're inside, so you won't be meeting much until and unless you come outside and meet or interact with your neighbor or with that person. So the members who are outside, suppose your mummy or your papa or your father or your mother, will be interacting with that person. So as you are inside the house, you will be or inside your room, you will be remain uninteractive or unaffected. Similarly happens with these crystals and the electrons within them. The overlap or interaction will be more felt in the outermost orbit while the innermost remains unaffected. Therefore, in order to understand electron energies in Si and Ge crystals, we need to take in consideration the changes in the electrons in the outermost orbit only. Now let's dive into the understanding or explanation. We have taken two atoms or crystals, silicon and Ge. So silicon or Si have 3 orbits around it atom. So now let us take for more easier thing, let number of orbits be small n while number of atoms be capital N. Outermost orbit is the third orbit. So let n equal to 3. Similarly, for Ge, we know that it has 4 orbital paths. So similarly, as we have taken for Si, we will be taking for Ge. Let the number of orbits be small n and number of atoms be capital N. Outermost orbit is the 4th orbit, which is n equal to 4. And as we know, that this n equal to 4 is 2s and 2p electrons. So the total number of outer electron in the crystal is 4n. But we all know the maximum outer electron to complete, total how much it can hold is possible, is 8. That is the maximum number to complete the K shell or M shell orbit, all those things. So it is maximum is 8 for each orbit to complete. So that is 2 electrons from S state and 6 electrons from P state. So that's why it has maximum possibility of 8 places to be filled of the orbits. But in GE we are only with the 4n electrons. So out of 4 electrons for GE, 2n electrons are in the S state and 2 from the P state. So obviously some P electron states are empty. Region A of the figure. The figure which we have know about the band solid state, those from that figure we can come to see. Those who are having NCERT book can refer the book for further easy thing. Now these 6 and so the 6 electrons which are left out are isolated electrons. Now let us assume that these atoms start coming nearer to each other to form a solid. The electrons' energies are interacting in the outermost area, as we have known, or orbit, that will change, increase or decrease due to interaction between different atoms as they are coming closer. The Si and Ge atoms are coming closer to form a solid. So the outermost orbit energy will be changing as they are coming to each other or colliding and bombarding with each other. Before moving further, now let's see the diagram again. This is the diagram. Region A is the region of the isolated atoms. Now the 6n states for L equal to 1, which had identical energy due to isolation, spread out and form a energy band. Similarly, for 2n states, those who are in the outermost part having identical energy in the isolated atoms, split into a second band separated from the first form of energy band by a gap called the energy gap. So the completion of two bands, that is first energy band and second energy band, have taken place, and a gap has formed between them. This gap is called the energy gap. Now due to small spacing or small energy gaps comes a place where bands merge with each other. In the diagram, region C is the place where identical atoms merge with each other to form a band. Before moving into next thing, let's see or look into the diagram again. This is the diagram, and the region C is the region where electrons of the atom are interacting. That is, the outermost region is region C, where all those interaction is happening. And now finally, the distance between the atoms further decreases. The energy bands again split apart and are now separated by an energy gap. Again, let's move into the diagram. This is called the energy gap and is known by the region D. Now the empty spaces, or the 8 atom spaces which were empty, as we knew earlier that there were maximum possible 8 atoms to be accommodated, but these 8 atoms were empty due to filled up of 4n only from the S state. Now, so the empty spaces are equally now redistributed or reapportioned between two conduction and valence bands. Now significant point is that There are exactly as many states in the lower band 4n as there are available valence electrons from the atoms. Therefore, this band called the valence band is completely filled while the upper band is completely empty. This upper band is called conduction band. Thank you. That's all for today. Thanks a lot for hearing my video patiently and sparing some time to it. I hope this video has been a helpful one. Signing off. See you later.